Welcome to Wireless Visionaries. When we talk about MIMO, we mean that we have multiple antennas at the transmitting end and multiple antennas at the receiver end. And the signals are sent simultaneously from the transmitting end, they propagate through the channel, and finally received at the receiving end and processed. So when we talk about CISO link, that is single input, single output, we have this relationship y is equal to hx plus n, where x is the transmitted baseband signal, n is the noise with respect to the receiver component, and h represents the channel. So this is the simplest form of relationship when we talk about non-convolving channel or flat fading channels. So in MIMO, we have, since multiple antennas transmit signals simultaneously and they propagate through channel, so the signal received at one antenna is the sum of the multiple signals transmitted from multiple antennas multiplied by their channel coefficient. So we have, so signal received at one antenna is represented by h1 x1 plus h2 x2 so on up to h and t x and t, where nt is the total number of transmitting antennas at the transmitter side. So this is the form of relationship that we have in case of MIMO. So the very first benefit of MIMO is the diversity gain. So diversity gain help us to overcome the effects of small scale fading by using diversity combining, and overcome the effects of path loss by using the array gain. Now what is diversity combining? So by diversity combining, we mean that if we have two copies of a single signal, for example, if we have this one copy and we have another copy of the same signal, so we mean that at any instant of time, the signal received is always greater than the threshold value. In contrast to the case if we consider only one signal which is low at this instant of time, or the other signal which is low at this instant of time. So as a result of diversity combining, we always get a signal greater than the threshold at any given instant of time. So second is array gain. So by array gain, we mean that the signal received at all the antennas, they are combined in such a fashion that we get a combined SNR which is at a much higher level. For example, if we have the multiple signals coming at different SNR values, this is one signal. If we have another signal coming at another SNR value, if we have another signal, and these all signals, they are combined in such a fashion that we get a combined SNR which is much higher than the signals received at different SNR values. So this is the advantage of array gain. So as a result of this combined SNR, we get an average improved received signal strength at the receiver. So the next benefit of MIMO is we get increase in capacity, and this increase in capacity is because of the spatial multiplexing. So the word multiplexing means that we have simultaneous transmission of signals to the ground users, or several data streams, they are mixed together for transmission. So as a result of this spatial multiplexing, the transmitter has the capability to serve multiple ground users by forming separate beams. Or it can also serve the same ground user by transmitting different data streams. So as a result, we have this parallel stream transmission. So the next benefit of MIMO is beamforming. So beamforming, what is beamforming and how it is achieved, we have covered this in our previous video. So with beamforming, beams which are very narrow and directional, they are formed towards the user direction, and the signal is sent in a very directive manner towards the users. So this also helps in reducing the interference between the ground users. So because of all the benefits, for example, this spatial diversity, spatial multiplexing and beamforming, we get a linear increase in capacity in comparison to the CISO when we increase the number of antennas at the transmitting end and the number of antennas at the receiving end. So this is what MIMO has brought to us.